Yeah, my screen is visible.
Yes, sir, you are visible.
Yeah. So just last class we stopped in between due to insufficient time. Now we'll continue. Just I will reveal once again. This is little bit lengthy problems, but it is simple only. We'll see. The question is the whether we are going to play tennis or not, or something else, any game. For that, the outside climates are like this. We can say outlook is sunny or overcast or rainy. Like this, there is a features, and temperature is another attribute, and humidity another one, and windy. So by considering these three conditions or four conditions, you need to decide whether you're going for to play tennis or not. That is the question. In that, the thing is here, they mention, suppose if the outlook is sunny, temperature is hot, humidity is normal, windy is true, means wind is there, then whether you are going to play tennis or not. That is the question. In that, we can see, I already explained some portion, just will reveal once again and we'll complete this problem. And in this case, as you know, four attributes. These are the four attributes. And one is a target, that is a play, yes or no is a your target. So it is also is a binary classification because it is showing yes or no. That is only the thing. Now in that, one by one, first decision is whether which attribute you are going to take a decision tree, I mean root tree, root node. In that, among four are there, no? Anything can take it as a root node, but optimal thing to get as a minimum leaves and all, we'll go with as a optimal decision. In that, whether I want to take it as a outlook is a root node. Root node means starting node, and our temperature is a root node, or humidity or windy, anything. For that, you have to calculate something. Uh, the calculation portion. In that, first I will take it as a outlook is a root node, then we'll calculate the error. Similarly, temperature you take it and find the error and humidity and so on. From that, you can decide which is your root node. Now, first I consider as outlook. In outlook, what are the additional features are there? Sunny is one condition, overcast is another condition, rainy is another three. So in that three, you have to set the rules also. First, outlook. In this three, I taken overcast, sunny, rainy. In that, how many count? You can simply count here. Sunny, how many? 1, 2, 3, 4, 5. So these are the sunny 5. And similarly, overcast 1, 2, 3, 4. 4 is the overcast. Like that, you just fill the table. Our intention to find the error. So which is having minimum error, you pick up that. That is only the intention. Now this table, simple table from the observation of the given data. Overcast is 4 count, sunny is 5 count, rainy is 5. So out of 14, you can see total is 14 out of 14. These are the classification. In that, target. This one is a comparatively target side. How many yeses are there? How many no's are there with respect to sunny, with respect to overcast, with respect to rainy? Like that. Now overcast is 4. In that, yeses are 4, no's are 0. Similarly, sunny, yeses are 2, no's are 3. And rainy among 5, 3 yes, 2 no. Now that's what I mentioned here. 4 attributes to decide which one is the root node. For that, we need to find the minimum error. Now for that, we write a rules. This is the table directly comes from the input data or the given problem. From the table, we have to write a rules. What are the rules you have to write? First, all the three parameters you have to consider. Suppose overcast is your, for this I have to write a rule. What is the rule I write written here? Overcast is yes. So why I taken as a overcast is yes is a better rule to get low error. The reason is among four, all fours are yes. So overcast is yes. That means this overcast is equal to yes is a rule. If it is taken no, then no such target is there in the overcast case. That means probably if overcast is yes, it will be target is yes. So that means you are going to play cricket. That's what I mentioned here. Rule, if overcast is yes, there is a 4 classified correctly, because 4 classifications are correct, 4 instances are correct, and 0 will be classified as incorrectly. That means the rule is overcast is yes is our rule. That's what we can take it. Why not taken as overcast is no? Because overcast is no is not a yes. It is a 4 times or yes here, or your prediction is yes, but this will be no. That's why you can take it as a, that's what I mentioned the rule also. If I take overcast is yes, 4 will be correctly classified, but 0 will be classified incorrectly. That's why if I write overcast is no, 0 will be classified correctly. That is the rule you can see. If meaning is overcast is no, means 0 will be classified correctly. So we don't want 0 will be correctly. No, we want maximum will be correctly. That is the reason. And 4 will be classified incorrectly. If I make rule overcast is no, then your thing will be, what will happen? 0 will be classified correctly and 4 will be classified incorrectly. That is the reason I taken overcast is S is our rule. Similarly, we can go for overcast is S is our rule. Now, how to calculate the error now for this overcast case? So overcast is yes. I got it as a 0 by 4. What is meaning of 0 by 4? The formula of error is number of incorrects divided by total. That is only formula. So error formula is number of incorrect divided by total. What is number of incorrect here? If I take overcast is yes, then you can see if I take overcast is yes, then 0 will be classified incorrectly. Then as per our formula, incorrect count divided by total. So that is the reason error 0 by total is how many? This total is 4. Now we'll get the error also. Now similarly, you consider Sunny. You can come to Sunny total 5. Among that, if I take Sunny is a yes, then what will happen? 2 will be correctly, 3 will be incorrectly. If I take rule Sunny is yes, then I can write 2 will be correctly and 3 will be incorrectly. Then as per our formula, error formula, number of incorrects divided by total. So number of incorrect is 3 divided by total is 5. This is the case of error. If I take a rule, Sunny is yes. This is the error. I can write this is a error is equal to 3 by 5. And whereas if I take Sunny is no, rule is instead of taking Sunny is yes is a rule. Now you take it Sunny is a no. Then number of corrects are 3, number of incorrects are 2. Then what is your error? 2 by 5. Then which is minimum error now you can see 3 by 5 or 2 by 5. So minimum error is 2 by 5. That is the reason I taken rule Sunny is no. Is it clear all of you? You have any doubt you can ask me. It is small logic. After that it will be same. Nothing is there. So now rules, while you are writing the rules after this table you have to write a rule. In that table overcast is I taken as yes. Then I can write 4 will be predicted correctly, 0 will be incorrectly. That is the reason the error will be 0 by 4. Incorrect divided by total is your formula of error. That will be rule is overcast is yes. Now Sunny. If I take Sunny is yes, then your error will be incorrect by correct. Now incorrect is 3, total is, incorrect by total, 3 by 5 will get. That is the reason I taken Sunny is no, is our rule. Then your error will be sunny is no means what? 3 will be correct, 2 will be incorrect. So incorrect 2 by 5. I will write 2 by 5. Then rainy. Last one is rainy. So if I take rainy is yes, then what is your formula? Rainy is yes, then 3 will be predicted correctly, classified. 2 will be classified incorrectly. Then error is incorrectly divided by total. So 2 by 5 will get it as a this formula. That is the reason I taken as a rainy is a yes. Otherwise, suppose if you take rainy is no. Rainy is no. Then what is your formula now? Error calculation. Rainy is no means rainy is no. Then 2 will be classified correctly. 3 will be classified as incorrectly. So incorrectly divided by total. So incorrectly is 5. Then total, 3, total is 5. Then your error will be 3 by 5. Instead of 2 by 5, you may get 3 by 5. That is the reason you have to take it as a rule such a way that error must be minimum. Now I write the rules from the above table. From this table, I wrote the rules. So sunny is no is the best one, and then rainy is yes is best one, then overcast is yes is the best one. Or indirectly I can say in thumb rule, which is having highest count, that you take it as a rule in each case. So highest count is 4. That means overcast is 4. Then here highest count is 3. Therefore sunny is no. 3 related to no. And then rainy is classified 3 will be yes and 2 will be incorrectly classified. That's why rule is rainy is yes. So like that. Now how to calculate the error? Reversely. Now what I did is highest is taken as a rule and lowest is the error. Now that lowest divided by total. So that means incorrect divided by total is your formula. Now you got all these things error. Then how will you calculate the total error? Sum of this we can consider as a total error. This is 2 by 5, then 0 by 4, then 2 by 5. So you can add these numerators. You will get the total incorrects. Here 2 incorrect, here 0 is incorrect, this is 2 is incorrect. So the formula is incorrect divided by total. This is the formula. Total is 14 instance. The incorrect is 4. Then we got it as a total error. If I take it, Outlook is your root node. That is one point. But we cannot conclude if Outlook is a root node. One I taken Outlooks. Next one, what I had to take? Temperature. Now one we calculated the error, total error. 4 by 14 is your total error. You can see that 4 by 14 your total error. If I take Outlook is your root node. Outlook is your root node. Next temperature we take it. So similarly, as per our data, temperature column, in that we have 3 classifications. One is hot, mild, cold. So hot is 4 instances, mild is 6 instances, cold is 4 instances. In that, again, we can classify how many yes classified correctly, how many classified incorrectly. So there is a 2 classified correctly. This yeses are 2, no's are 2, like that. You can check with the target target node. So after that, how to write this second table? Second table is very blindly you can write temperature is attribute. How to write a rule? As I mentioned in the case of Outlook, which value is highest value, that you take it as a rule. Now this both are same. You can see here both is same in this case, but I taken hot is equal to no. You can observe that point. So temperature and humidity bind also you have to do it. And similarly, I have taken anyone. Let it be hot is no is a rule, and mild 4 is classified correctly. Therefore, mild is yes. You take it mild is yes. And 3 is classified correctly. Then cold is yes. These are the rules. Once if you know the rule, then you can easily calculate the error. How will you get the error? Incorrect divided by total. How many incorrects? 2 are same. No? 2 incorrect out of 4. And here incorrects are 2. That's why 2 by 6. And here incorrect is 1. That's what I taken as a 1 by 4. And 2 plus 2 plus 1, 5 out of 14. So earlier it was 4 by 14, but now it is a 5 by 14. If I take temperature is a attribute, is a root node, then your error become 5 by 14. But outlook is your root node, error become 4 by 14. Now, third one you can see humidity and wind. So third one is humidity, fourth one is a windy. Humidity, two attributes are given, height and normal. So humidity, high and normal. So high is classified 7, normal is classified 7 if as per the target table or a target attribute. In that, S's are 3, no's are 4. Now anyone can tell me what is the rule I have to write for high case, because which is having highest number that we consider as a rule, because no is 4 means classified 4 correctly and 3 incorrectly. If I take rule is no, because high is no, then classified 4 is correctly, 3 is incorrectly. Your error is 3 by 7, because incorrect divided by total is your error. Similarly, normal total is 7 is there. In that 6 will be classified correctly, 1 will be incorrectly. If I take normal is a yes. That's why I take a normal is yes. We'll get error, means incorrect is 1 divided by 7. Now we'll get it as a, this one is humidity, 4 by 14 we'll get it. And similarly, windy you take it. Total is 8 is false and 6 yes. Now, what is rule I have to take? Which one is highest? 6 is highest. Then false is yes. And whereas here highest are same, let it be both are same. You take it as a anyone. Let it be true is a no. Anything you can take it. True is no. Then we'll get it as a 3 by 6. Then false is yes. You can take it as a this 6 times are classified correctly and 2 times are incorrectly. So incorrect divided by total 2 by 8. That will get 2 by 8. Then your error will be 5 by 15. 5 by 14 is your error. Now your error is 5 by 14. Now you take it from all the attributes. First attribute is outlook. We got it 4 by 14. And if it is taken as the root node, error is 4 by 14. Temperature is the root node 5 by 14. Then humidity is 4 by 14. And windy is 5 by 14. So these are the final classification. You got it. So that means outlook is the root node, error is this much, temperature, error is this much, humidity, error is this much, and windy is this much. So which one is the least one? We have to take it. Minimum error is a outlook or a humidity, because both values 4 by 14, this humidity also 4 by 14. So now, so which one has to select? Because this humidity as well as outlook also consider as a, what you call it as a minimum error comparatively other two. So you discard these two. Now any one, how to select this again? We can see here classified incorrectly how many? 4 in this case, even though values we can observe 4 by 14, and whereas humidity also 4 by 14. So in this case, there is a 3 plus 1, 4, 4 by 14, and here also 4 by 14. So we need to check individual errors also, because both are same. In this case, we have to go for as a individual errors as well. We need to check individual errors, humidity case as well as the outlook case. In the observation, outlook overcast is yes and gives 0 error. You can see overcast is yes, then your error is 0. And select the overcast is your root node. That is, select the individual error is minimum, select that attribute. So now we can observe the instance, if both are same, how to select as a root node. This one as well as this one, both are same. But now individual errors you calculate 2 by 5, 0 by 4, 2 by 5. Similarly, 3 by 7, 1 by 7. Among the 5, this may be minimum error. That's why you select overcast is your root node. So here error is 0. We are able to get error in this overcast is yes, we are getting as a 0 error. So like that, anytime if you get equal weightage, you can see in this case also, you can observe why I taken the rule in the case of here. Yeah, both is 2 and 2. So in this case, because both is 2 and 2, that is the reason I taken as a no, because here exactly again 2 by 4 and then 2 by 4 will get it. And similarly, in this case, there is anything you want to select, individual error you have to calculate if it is same. But whereas all these things, you can check it here 3, 3. But anyhow, if I take S also 3 by 6 or no also 3 by 6 will get it. So that's why anyone you can random. But here, if both total errors are maybe the same, but individual errors you can calculate. What is individual error? 2 by 5, 0 by 4, 2 by 5. Whereas here also 3 by 7, 1 by 7. So if individual errors are different, which one is having minimum, that you take it as a final root node. Now, as on now, what is happening? We selected outcast is our root node. Then you divide the classification. In how many, in the outcast, we discussed how many features they are given: sunny, overcast, rainy. This 3. From now, I consider outlook is our root node and split these parameter. Sunny is one parameter, rainy is another parameter, and overcast is another parameter. Anyhow, we decided overcast is yes is a minimum error. That's why we can consider this is a leaf node. So further, it will not be divided anything. Overcast is yes is concluded. But whereas in this case, if we go sunny, then rainy. So as per problem, you can see here, we'll copy this. One, if you understand, then it will be easy for you. We'll copy this. Yeah, here I will paste. Now you see, first you have to select the root node. As per root node, I already taken overcast is your outlook is your root node as per calculation part, which is minimum error. We got it. In the outlook, again, how many things are there? Sunny is there, overcast is there, and rainy is there. In that, which is yes, I concluded already because it is a minimum error. The in outlook, overcast is yes, is your closed. And remaining is what? Sunny. Another one is a rainy. So sunny, you take it. The rest part, you can write it here. And similarly, rainy part, you can write here. So rainy and sunny, you can observe the table which is related to that. Suppose we take sunny. Sunny case, what are the parameters are there? These 3 parameters, we are dividing now. Sunny, hot, then high, then false. This will be one category. And again, sunny is there, then hot, then high, then true. This is to second row because I'm writing this. What I'm showing you is first sunny related to features. I'm writing sunny, hot, this one, this row you can write. Then second row you can write. Then sunny, where it is there? Yeah, this one, mild, high, false can write. That's what I wrote here, mild, high, false. And target also can write play. Play is your target, related to target. Same thing, that row, sunny row, as such you can write. And another sunny, cold, normal, false, yes. You can write cold, normal, false, yes. Then another sunny is 1, 2, 3, 4. 1, 2, 3, 5. Another sunny somewhere, yeah. Here, this you can write. Mild, normal, true, and yes. So now we got this subtree. And here, similarly, you take it as a rainy. What is the rain? Wherever rainy is there, you write it. Yeah, this is rainy. You can write this row as such. I wrote this row. Then another rainy, this row. You can write this row as such. Then third rainy. This one is third rainy. Then another mild rainy. Yeah, this one you can write. This one you can write. So now I wrote this. Now what will happen? Directly, two things are completed, sunny and rainy. But overcast, I am not writing this remaining part because overcast is yes is concluded as per the root node. Overcast is yes here. That's why automatically this also overcast is yes. This also overcast is yes. Then this also yes. This also yes. That's why you can write overcast is equal to yes. So now the question is, now let's treat this is a problem. Like what we treat this is a problem, how we divided as a root node. Similar fashion, repeat this problem considering this is your first table attachment. Now how to find the root node? Again, instead of 4 calculations earlier, now you take it as a 3 calculations. This temperature, humidity, windy is your features and find out which is the minimum error. You will get it as a another node here from this 3. In the either this or this or this one will get it. Then once if you know that, the remaining part again you make it as a table. Similar fashion, you find temperature, humidity, windy is your root nodes now are features. In that you have to identify root node, how you calculated the outlook. This problem has to repeat it continuously until you get it as a final leaf node. Now we'll proceed this problem as such. Now I mentioned no temperature, humidity, windy, play is your starting problem. How we started this data previously and how we calculated and we concluded outlook is your root node. Same manner, you take this is your problem and identify your root node for this case. Similarly, this is your problem and same procedure you do it and identify or any one from this will be as a root node. We'll get it now. We can see here again, I taken temperature, humidity, windy. This one, temperature, humidity, windy. Now we have to write temperature is hot, cold, everything. Whatever we have, this thing as such you can write here. And then attributes. Now same table, first is this is the problem now. We have to write the rules. How to write the rules? Blind rule I told already. Instead of 2 tables, I directly am writing here. First to take it as a temperature your attribute. Second is humidity. Third is wind. Earlier each one attribute I taken as a table separately. But now you came to understand the logic. That's why I taken as a one table straight away. Temperature, then humidity, windy. I taken 3 attributes and each attributes how many features are there? Hot and cold. This 2. Hot, mild, cold. 3 are to write. Hot, mild, cold. That you can see. Hot is no because in the output side. Then again what we can write and you can count the error based on that. We can able to select the rule. If I take heart is a suppose anything heart is, yeah, both are no only. So therefore, hot is no is your rule. Hot is no. Then how many features, I mean, how many classifications are correctly predicted and how many incorrectly predicted? Two hearts are there. Heart is no, heart is no. Therefore, two classified correctly. Then incorrect is 0. So 0 by total. Total is 2. 0 by 2 is your error. Similarly, you come to mild. Mild, two things are there. High, one no. And mild normal, one yes. So that's why you can take any one is a mild. Mild no, if I take 1 by 2 will get. Or mild yes, you can take also 1 by 2 because only 2 is there. One is correctly predicted, another one is incorrectly predicted. In that case, then similarly, you take it as a humidity. And humidity, what is the humidity case? How many features? High and normal. Now you can able to tell. If I take high, how many? 3 predicted correctly. 3 correctly. If I take normal is the rule, 2 will be this. That means if I take humidity is high, then corrected 3 classified, 2 classified. Error is incorrect divided by total 2 by 5. Or if I take humidity is normal, 2 will be correctly classified, 3 will be incorrectly classified. That's why 3 by 5 will get. So therefore, which is minimum? 2 by 5 is minimum. That is the reason I can take it humidity high is a no. High is no. This is the rule. We'll get it as a no means 3 predicted correctly humidity case. High is no if I take 3 predicted correctly, and that is the reason. And there is a yeah, only I is no. If we take, then the error incorrectly is 0. So that's why 0 by 3 will get it. Another one is a humidity is normal. So you can see that humidity normal is false. You will get one prediction correctly and one prediction incorrectly. Normal is true, also vice versa. Then you take it normal, humidity is normal is yes. So normal is yes, both are yes. Yeah. So you can take it as a normal is yes. Just a minute. Yeah. So this two normal case, both are yes. Therefore, your rule is normal yes. In that case, correctly is 2, incorrectly is 0. Formula is incorrect by total. So 0 by 2 is your error. So you can write 0 by 2 your error. Now we'll come to windy. Windy, how many classifications? False, true. 2 classification. How many false? It is no. When if I take windy, false is no. 1, 2, and false is no is 2. And if I take true, then where you can see that false is no, I got it as a 1, 2, I mean windy case, 2, 3, one category, 2 is another category. That's why we can write false is no. If false is no, you will get 3 classifications and 1 incorrect. Then you can say 1 by 3, and true is yes. I can take 1 by 2 is incorrect by total. So we'll get these are the 3 errors. Now which one is the next root node? Anybody? Which is having minimum error. So now this is your 0 error. That's why humidity you take it as a next leaf node. That's what in this humidity is minimum error. So select the humidity. But already one outlook is your main. This is outlook is your main. In that there is a this one is yes. You can close here. Then like this. Now again you take it as a humidity is your another node. That's what I can consider. This outlook overcast. Yes, this is closed. This part is already from the previous calculation. It is closed. And another calculation sunny, rainy. In that I have to find the which one is a minimum. Now we can write humidity is a minimum. In that we can easily calculate humidity is a, yeah, this one. Just a minute. Yeah, so humidity is having 0.5. So that is your root node. In that, again, you can take it as a high is one side and then normal is another side. That's what we can take it. And this is the case, we'll get it as a left hand side. Similar fashion, you can do for a right hand side also. Which one is having minimum? Now windy is your right hand side leaf node. That's what we can get. You can see that windy right hand side windy, left hand side already calculated humidity. In that high and normal, which is the high is no or normal is yes. And similarly windy case, this is your classification. So now with decision tree, what is the problem? If they given the problem, now we can take it as a prediction problem. What they have given this one. So in this outlook is sunny and then temperature is hot, then humidity is normal, then windy is true, then what is your answer? This is the question. Now we can see in the last slide of this from the table. Now we can decide what is the question. Suppose what they asked is outlook is sunny. This is the outlook, then sunny, this point, then temperature is hot, then temperature is hot and humidity is normal. Yeah, humidity is normal. Then windy is true. Windy is true. Then what is your answer? That's what I have to write here. You can see outlook is sunny. Then humidity outlook is sunny and humidity is normal. Then we can say your answer is yes, we got the leaf node. So this is the way we have to identify. You can see outlook, we start with outlook because the given data is sunny. Then you have to go left hand side. Suppose this is mentioned outlook is a rainy. Then you have to come this side. So like that, you can move step by step and final node, leaf node you identify. So outlook is sunny. I taken outlook, it is a sunny. Then temperature is not here. That's why we don't want to go that side. Then because it is not a root node and humidity is normal because sunny after that humidity is normal. If it is humidity is given instead of normal, it is a high. Then what will happen? Humidity is high, your answer is no. But now humidity is normal. So humidity is normal. Then it will play is final leaf node is a yes. So like that. If any other combinations also, you can take it. Suppose outlook is rainy, then we'll come here. So the rainy is dividing two part like this, we'll get it. And based on the other parameter, you can choose whether we'll go to play or not. This is the way we have to divide the problem. And we'll see next problem also, decision tree only. The age is young, job is false, house is no, credit fair, and then loan approved. Yes. Now the question is, this is the problem. We need to find whether his loan is going to approve or not. So you take this is assignment also or some other problem also I will give it to you for your assignment and you can try to solve this type of problems so that it will decision tree is going to close. Now, what we have to do? Now, remember what procedure we followed so far. First, among this four, exact same as previous problem, four is a features. In that, which one you take it as a root node? Either age I have to take, job or house or credit. Any one you have to pick up. How to pick up that? Calculate the error and which is having minimum error that you take it as a what you call it as a root node. And loan approval is your target. This is your target. Now you start with the problem age. These are the parameters you remember. Age, job, house. So age is one, job is another parameter, house is another attribute, and credit is this 4. So among the 4, you divide first age. You take it age, find the error. How to find the error? In a age, we have 3 features. One is a young, middle age, old age. Then the number of youngs, how many youngs we have? 5, and here also 5, here also 5. And then we divide yes and no's. The 2 yeses are there, 3 no's. Similarly, 3, 2, 4, 1. Now we have to write a rule. What is the rule as per previously as I mentioned? If yes is which is having highest, you take that is a rule. And therefore, young is no. 3 times classified correctly, 2 incorrectly. That's why you can write yes is no is your rule. I mean, young is no is your rule. So young, no. And similarly, here you can see the middle age. How many years? 3 years. So therefore, middle age is yes. 3 classified correctly, 2 classified incorrectly. That's why I make it as a yes. Middle is yes is the rule. You can take it. And old is yes is your rule. So therefore old yes, because maximum is 4 correctly, no? That you can take it as a what you call it as rule. And now how to calculate the error? Once if you know this point, error is if rule is known, young is no. Thus young is no means this many classified correctly. Incorrect is 2. So formula of error is incorrect divided by total. Incorrect how many? 2. So therefore 2 by 5. Total is 5. And here incorrect is 2. 2 by 5. And here incorrect is 1. 1 by 5. So now total how many? 2 plus 2 plus 1. 5 by 15. So now this is the error. Remember this. If I take age is your root node, then 5 by 15 is your error. Now what is another job? You take it as a root node. And then house you can take it as a root node. Then credit you take it as a root node and calculate the errors. Similarly, I taken job. Job is yes or no. In that 10 will be the false and true only 5. So then in 10 again false is yes 4, false is no 6. What is the rule now? Which is having, if I take false is no is your rule, then predicted 6 correctly and 4 incorrectly. Therefore, 4 by 10 is your error. You take it 4 by 10. And true, here yes is taken as a 5 and no is taken as a 0. So therefore, if I take true is yes, then 5 classified correctly or 0 incorrectly, then error is 0 by 5. You'll get. So now your error is 4 by. If I take job is your root node, error is 4 by 15. Now when compared to the previous age is your root node, there we got 5 by 15. Now 4 by 15. Now up to now it is the best one. Then remaining home, then credit. These two house, I can see no and error we calculated 3 by 15. 3 by 15 if I take house. Then another one is credit. You got it as 3 by 15. Now you have to select which one is your root node. Now we can see age is 5 by 15 and then job is 4 by 15, 3 by 15. In this, you have to select the root node. So now again, these two are the same error. Then how to find individual error? You have to find 3 by 9 error, 0 by 6, 1 by 5, 2 by 6, 0 by 6. So again, there is a problem. Both cases, here also 0 by 4, here also 0 by 4. So either house or you can go for as a credit is your root node. So now any one you can take it because still individual errors also will be the same. Again, next error you can take it 3 by 9, this one. Then another error what we have, individual error if I take 1 by 5 and 2 by 6. So this also will get it as a 1 by 3 same. And then 1 by 5. So anything randomly, you can see if the individual errors are same, you can take it as any one error. Preferably, you can take it as a 0/6 is your minimum here, and 0/4 is also minimum here. If I take as a credit, we'll get 0/4 is your one thing, but these two errors maybe 1/5, that may become 3/11. In that case, here you can get 3/9. So now we can see. So this case will get, if we're removing that, 3/11 will get error. And whereas in this case, 3/9 will get the error. So that means only 1/3 will be there. Now you take it as a house is your root node. So like that, now you take house is your root node, and then house is root node, which is your minimum error. Let it be yes, yes. That is what we can take it. Now house SS, this will become as a leaf node. Rest portion you take it as a problem. Now again, instead of previous 4 attributes problem, now will become as a 3 attributes problem. Again repeat this. Now you take it as age is one attribute, job, credit. Again you calculate the errors, and in that one will be pick up again. You can see now it is a fresh problem like that. What we did for 4 attribute problem, now will become 3 attribute problem, and after that we are able to get these errors. Now this will become as a minimum error. Now take it as a job is your what? So next root. So earlier we already taken a house. So here again you take it as a house is no, then you make it as a job. Now like that we'll get it. See that house is no, we'll get as a job. In that false and no, true, no. So now it will become. We can now it is easily converged. The problem. We can see how to identify your final decision. Age. What is age? Young. Age is your young, and job. How can see house? No. Can see house root node as per given data. Yeah, see house is no. Then house is no. Come to this. Then in that job is false. Job is false. What is your answer? We'll get it as a no. So that's what I wrote. Here is a no. Is it clear? So now problem is over. Simply you have to take as a decision tree, and we can able to identify your result. The loan approval is no. It will not be approved for him because his house not there. Because house is no means you have to check with the job. Once if job also no, then what will happen? You can see that job also no, then your loan will not be accepted because house is not there, job is not there. That is the reason you will not get the loan. Similarly, any problem you can take it. Similarly, city size, average income, then local investors, then can awareness, then decision yes or no. This also you take 4 attributes. Then the question is like this: we have to decide whether you will decision is yes or no. In that case, for a city size, average income, local investments, then awareness data set, apply the decision tree algorithm, find the optimal decision tree. And you can see that first you take it as a city is attribute, then average income, all 4 attributes you take it and find the error. So first error is 3/12. Similarly, second error is 2/12. Then third error is 4/12. And fifth error is 3/12. And you tabulate it, which is the minimum error you calculate. And here is the minimum error. So average income, take it as a your root node. Once you identify the root node and what are the parameters, you can write this parameter as such. Average income IS. So you make it as a IS. Yeah, which one? This one is a middle, medium no, and this point, and then low is no, and then high. Yes, so this remaining is the root node. The rest of the nodes are what? The problem will become three features problem, and again solve these three. Which one is the minimum you identify? And you can see the city, all these things individually we taken, and problems are three. In that, which is the minimum? 1/6 here, 1/6 here. Again, if we go inside, this will become 0/1. This will become 0/3. And whereas still you can see that 0/2 and 0/1. What else left? This is a 1/3. And this is a half. Then we can take it as a the root node lowest earnest. So this is the root node. Now will become as a 2/2. Which one is your local investment? City size is your constraint. You take it to local investment and city side, and you can see your final matrix we are getting like this. Decision tree. In that, what is the average income? Whether is given average income is a medium. You can see the average income medium straight away will get the answer no. You can see average income is our root node. If it is high, then we'll go this way. If it is low, it will go this way. In medium also, it is saying no. So then your decision will be no. Like that, you can solve many number of problems. Gini index problems also, you can take it as I discussed previously. Information gain, Gini index problem. Like that, you can do some more problems. Anyhow, I will share this and you discuss. If you have any doubt, you can ask me. We'll solve next class. Some other algorithm will take it. Seven members are present. Then who are the absent? Roll numbers, anybody can tell me? Two members are absent. What is their roll number? Anybody? Three members absent. Okay, I will download the attendance also. Okay. Download attendance. Okay, fine. So if you have any doubt, ask me. Otherwise, you can leave. You can leave now.